Welcome to Study Loop.
So for part A, we're going to apply equation 1034, and we can say that the kinetic energy is equaling 1/2 times the moment of inertia times the angular acceleration, or the angular velocity squared. This is equaling 1/2 times the moment of inertia of a rod rotating about one end. Equaling 1/6 ml squared omega squared, and now we can solve. So the kinetic energy would be 1/6 times 0.42 kilograms multiplied by 0.75 meters quantity squared multiplied by 4.0 radians per second quantity squared. This is giving us 0.63 joules. For part B, we apply the conservation of energy, and we can say that here the rotational simply equal the gravitational potential energy, mgh. So we can say that h would simply be equal to the magnitude of the kinetic energy divided by the weight. So this would be equal to ml squared omega squared divided by mg, or rather 6 mg. The masses cancel out, and we find that this is going to be L squared omega squared divided by 6g. We can solve, so h would be equal to 0.75 meters quantity squared times 4.0 radians per second quantity squared divided by 6 times 9.80 meters per second squared. We have a maximum height rather, equaling to 0.153 meters. This would be our final answer for part B. That is the end of the solution. Thank you for watching.